name is Jochen Schmid and I'm a professor at University of Münster in Germany. And we have expertise in biotechnology. And so our part is to use microbial cell factories to convert the smaller fragments coming from the long PE, so the polyethylene, from the other colleagues from the work packages before. And we will use these cell factories to activate very specifically these chemically inert fragments. So that means our microbes really activate these shorter fragments to make them suitable to be polymerized again towards other polymers. I think this is quite essential because microbes can do it much better than chemistry, to be honest. I would say especially these microbial cell factories. So we use bacteria and also yeast for the specific chemical molecules we have to produce. So we need different organisms. And I think this is our expertise, so that we really also teach them, also by genetic engineering, that they do this conversion very efficiently and at very specific ends. So this is why microbes are really superior, because chemistry will do it over the whole long molecule and we only target specifically these ends to make them reactive and active again for the polymerization. And I think this is our expertise, using these microbial cell factories and also doing bioprocessing, so that we already start to make the process in a smaller scale, what can then be transferred to the industrial partners to really go to the large scale. So we're working in 1 to 2 liter bioreactors, and the colleagues, they will work in 1,000 liter bioreactors. So I would say that we get different molecules in lengths from the colleagues, breaking down the long polymer of polyethylene. And this is a task that we really use these different lengths, and we focus especially on the longer chain lengths to convert them to these new molecules. We call them diacids and also diols, so dialcohols. And these, especially these long chain dialcohols, they are very complex to produce. And I think the main innovation we really do is using these different fragments and specifically convert them to the molecules the colleagues need for the polymerization. And there, these alcohols, I think, is the most challenge, and therefore I believe also the biggest innovation we can contribute to.
It is very important because we can specifically do some reactions, and I'm a trained chemist, and there I saw that some reactions are very, very unspecific, and we get a lot of products that we don't want. But in nature we have microbes and enzymes that can actually do that and can lead us to molecules that otherwise we cannot reach with chemistry. And this is why I think this part is very important, and then we can go further on to make some sustainable polymers and plastics that we can use and recycle.
Technology is the functionalization, and without functionalization you cannot use the substrates as building blocks. So without our work it would not be possible to produce those new polymers that are then biodegradable. So yeah, we are doing the functionalization for really producing active building blocks.
I think for me it's also a social impact, because I want to demonstrate to the world how GMOs are actually our friends and what they can actually produce in a more biological and nice way.